I'm going to go through several questions here fairly quickly. What I suggest you do is pause each one at the question, read it, try to think how you might approach it, and then unpause it. So the first one here, we have a value meal package that will take a choice of 1 out of 5 drinks, 1 out of 5 sandwiches, and 1 out of 3 chips. The important part to realize here is that whatever you choose for your drink doesn't impact how many choices you have for your sandwich, which doesn't impact your choice for chips. So we can just multiply, since they're independent, 5 times 5 times 3, and that would give us 75. Submit that. Move on to the next one. So go ahead and pause it here. Okay. We need to buy 4 collars, and each one has a choice of 9 different colors. This is the important part here. Repetitions are allowed. So if we choose red for the first dog, we could still choose red for the second, the third, or even the fourth dog. So we would have 9 choices for the first dog, 9 choices for the second, 9 for the third, and 9 for the fourth. Again, they're independent. Whatever we choose previously doesn't impact the number of choices we have for the next ones. So this would be 9 to the fourth, which would be, that would just be 9 to the 4th power, and that would give us 6561. Okay, so here repetition of colors are not allowed. This means that we have 9 colors for the first dog's collar, and then the second one, regardless of what choice we chose for the first collar, we have 8 choices left for the second one. So now it becomes 9 times 8 times 7 times 6. So let's clear that, and we'll do 9 times 8 times 7 times 6. 3024. So quite a bit less than if repetitions were allowed. Okay, 7 factorial. If you have a graphing calculator, which you really should for this course, there should be a place to do factorials, and you can look that up. Just Google it. Google the type of calculator you have and how to do a factorial on it. In this case, I have a factorial button that looks like that to give me 5040. It may be tucked up in one of the menus also. Okay. So she's looking to rent 3 movies, and she has 6 horror films and 15 documentaries. It's pretty important to notice here, we don't need to get 1 horror film and 1 documentary or 2 documentaries. It doesn't really tell us how many of each type we need. So there's not really any difference between these two for this question. So that would be 21 different movies to choose from, and she would be choosing 3 of them. So this becomes 21, choose 3. That's a combination. Again, you can use a calculator to do that. I don't have that on the scientific calculator, but you should have it on any graphing calculator. Again, if you're not sure how to do it, either check in with a tutor, or easiest would be just Google it, the type of calculator you have and how to do combinations or permutations. So this would be 21, choose 3. Okay, and 21, choose 3 should give you 1330. So here it changes a little bit because now we do have a limitation on how many of each to get. So really there's 2 cases here. She could either get 2 documentaries and 1 horror film, or she could get 3 documentaries. So these two cases are going to be separate ways of getting a combination of 3 movies. We want to figure out what each of these numbers is, and then we want to add them. So whenever we divide it into separate cases, where each case gives us full combinations, full solutions, but different types of solutions, then we add them together at the end to get the total number of solutions. So the first way would be to get 2 documentaries and 1 horror film. So that would be 15 choose 2, and again that's a combination, times 6 choose 1. 15 choose 2 times 6 choose 1. Alright, and I'm just doing this on Google really quickly, but again, any graphing calculator will do this. So 15 choose 2, 6 choose 1 is just the same as 6, so I'm writing it 6. You could put in 6 choose 1. And then I'm adding that to the other situation where you choose 3 documentaries out of the 15, so that would be 15 choose 3. And when we add these two numbers, we get 1085. Okay, this P here, so if this was a C, this would be just like what we had done in the last couple problems. It would be 8 choose 4. This is permutation of 8 where you're taking 4 of them. Most calculators will do this. I often find it easiest just to type them out. So basically it's saying that you're starting with 8 and you're going to move down towards 1, but you're only taking the first 4 numbers is one way to look at that. You have 8 choices for the first time. Think about it as no repetitions being allowed, very similar to that dog collar problem. And this would give us 1680. And again, your calculator should do this directly. If you can't figure that out, let me know. And how many ways can the letters in the word Alaska? So here, if there were distinct letters, if all of these letters were different, notice that there's 6 letters here. It would just be 6 factorial ways to arrange this. However, because the A's create duplicates, we have to divide by the number of duplicates created by those A's. That way, if we would just switch this A and this A, it would actually still be the same arrangement. So we're accounting for that fact that things are occurring more than once. So 6 factorial, and then anything that's duplicated, we want to divide that out. So in this case, we just have the A's, so it would be 3 factorial that we're dividing by. If there'd be another letter, for example, if there would be 2 S's here, then we would divide by 2 factorial also. But this would just be 6 factorial divided by 3 factorial. And that gives us 120. And we're assuming the capital A and lowercase a are the same there, by the way. Okay, it takes a bit of reading to get your head around here. We have 3 different types of songs. If you're wanting to play 12 songs and you have 3 different genres that you're playing from, and you want to play an equal number of each, it's kind of, you have to read a little bit between the lines here to realize that that means 4 country, 4 reggae, and 4 pop. So the first step would be choosing which of each genre we're going to play. That would give us 22 choose 4 times 11 choose 4 times 5 choose 4. But that only gives us which songs we're going to play, and it doesn't say what order we're going to play them in. So we're also going to have to deal with that. So we have, let me do this here. 4 times, let me just double check those numbers again, 11. This is going to be a pretty big number, which is why they mention the scientific notation. Okay, so that right there will get us our 12 songs. This will give us all the different ways of choosing 4 each from the 3 genres. But if you think about having 12 songs, even after you've chosen the 12 songs, you need to somehow put them in order. And you're putting them all in order. So if you think about the first song on your playlist, you have 12 choices of which of these 12 songs it is. The second choice would be 11 different songs to choose from, then 10, then 9, and it's going to end up being 12 factorial. Because you're going to order all 12 of those songs that you've chosen. This is going to be a really big number. So notice they said round it to the nearest hundreds. That's 5.78 times 10 to the 15th. So we will put 5.78 times 10 to the 15th.